Hello class, welcome to week 2 videos of Math 110. We're going to cover chapter 2 this week, and we're going to start off with section 2.1, number 41. This is asking us to solve an equation and then determine whether the equation is identity or if it's a contradiction. So the first thing we notice is there's a lot going on with this equation. We have parentheses, we have brackets, so we want to make sure that we're working the problem in the proper order. Okay, so order of operations tells us to work with our parentheses and brackets first. So the way that works is, notice that we have parentheses on both sides, so we can technically work either of those. On the left side, notice that we have a bracket, and then inside the bracket is parentheses. So I want to work on the inside and work my way out for this one on the left. 3 plus 4x, those aren't like terms, so there's nothing I can do there. I do notice that there's a negative 1 in front. So I'm going to go ahead and distribute that in. What that's going to do is that's multiplication, negative 1 times everything else. So I'm going to get 7 bracket 2. So notice how I just keep rewriting things as we work through this problem. Negative 1 times 3 is negative 3. Negative 1 times negative 4x is negative 4x, or sorry, negative 1 times positive 4x is negative. Okay. Close my bracket. Minus 2x equals negative 9 plus, now again we have parentheses over here, and we're distributing a positive 2 inside. So we get plus 2 minus 30x. And we've distributed a positive 2 into both of those. All right. We can check to see, do we have any like terms? Well, 2 minus 3 inside my brackets, those are like terms. So I have negative 1 from 2 minus 3 minus 4x bracket negative 2x equals, on the right side, negative 9 plus 2. I have a couple extra plus sign here. So negative 9 plus 2 is negative 7, and we still have the minus 30x. Okay. So it's good to collect your like terms as you go. Technically, we could have distributed the 7 in without collecting the like terms and then collect them after. You would still get the same answer. Alright, so now we have a 7 on the outside that we're going to distribute in. So that gives me negative 7 minus 28x. And then the minus 2 x equals negative 7 minus 30x. Okay. We have some like terms on the left side. So we have negative 7, negative 28x minus 2x gives me negative 30x equals negative 7 minus 30x. Okay. We want the x's on the same side, so I'm going to take this minus 30 over here on the right side and add it over. The opposite of subtraction is addition. So add it over. There should be a 30x there. Okay. There we go. Okay, so when I add that over, the negative 7 is still there. Now, negative 30x plus 30x, that's actually 0. Those are going to cancel out, so I have negative 7 on the other side. Negative 30 plus 30 is also 0. So notice that the x's canceled out, and I'm left with just numbers. So this is one of our special cases, and we want to check to see what's going on. Well, negative 7 equals negative 7. That's a true statement. Okay, that's going to be important. If we ended up with negative 7 equals maybe 4, that would be a false statement. That's going to give us something different. So when we have a true statement, that tells me that I have an infinite number of solutions. Meaning, I can plug in any number that I want. So if I plugged in 6 to this, it will work. If I plug in 1 million, it will work. So if you wanted to check, you could randomly pick a number and plug it in, and it should give you a true statement. What it also tells us that this is an identity. Since we ended up with a true statement, infinite number of solutions, this is also considered an identity because we have this true statement. Okay. So that's working through solving an equation, one of your special cases. Let's move on to section 2.2, which is dealing with looking at some formulas. Section 2.2 is still solving, but we're solving for specific variables. All this means is we're going to move everything around. All the variables we're going to move around so that we have it solved for the variable that we're worried about. So in part A, it's telling me take this area formula. So we have area equals 1/2 times h times b plus b. Notice one's lowercase, one's capital. That does make a difference, so you want to keep track of that. Okay, so solving for h means I want h to be the only thing left on this side of the equation. So when I get done with this, it should be h all by itself, everything else pushed away from it. Okay. So the first thing I notice is h is being multiplied by 1/2. So to move the 1/2 over, I multiply by the reciprocal, which means I multiply by 2. So that leaves me with 2a equals, these are going to reduce out, leaving me with just h times b plus b. So we went ahead and moved the 1/2 over. Now I notice, well, h is being multiplied by b plus b. So I can undo that multiplication with division. Technically, we could have done both of these steps at once, but I like to show them as 2 steps. So when I divide over here on the right side, these will reduce. Notice that all I'm going to be left with is that h. That's what we're trying to get to. Now on the left side, we check and see, does this simplify at all? Well, there aren't any like terms or any like factors to reduce out. So we keep it as 2a over b plus b. Be careful when you're plugging it into Math Excel. The lowercase b and the capital B will make a difference. So you want to make sure you're plugging that in correctly. Okay. Now we're going to use the exact same formula. A equals 1/2 h times little b plus big B. And this time I'm going to solve for b. So my goal is going to be to move everything over just like we did, but we want b to stay behind. So my final answer, I want b equals. Well, I've already identified how to move the 1/2 over by multiplying by 2. So I'm going to go ahead and multiply by 2, or 2 over 1 on both sides. So that gives me 2a equals h times b plus b. Well, I want to try to get that capital B by itself. So if I distribute this h in, it's going to be multiplied. So I'm going to create another step. So what I'm going to do is I'm going to get rid of this h now by dividing by h. So what that does for me, that gives me 2a over h equals, these reduce, leaving me with just b plus b. And then subtract b, and that should give us our final answer. So let's move this a little lower. So we have 2a over h minus b equals capital B. So remember, as I work through these, if I'm working too fast or if you just don't quite get it, you can always rewind me, put me on pause, do what you need to do to make sure that you can get caught up and understand the material. So we'll move on to 2.2. If you're not ready to move on, remember you can rewind me. Okay, so this is number 25 in 2.2. So we're dealing with converting between Fahrenheit and Celsius. So there is a formula for that. So we have F for Fahrenheit equals 9/5 times C for Celsius plus 32. So as of 2009, the highest temperature ever recorded in Tennessee was 45 degrees Celsius. So this is Celsius. Find the corresponding Fahrenheit. So what that's telling me is if I know the Celsius, I can go ahead and plug that in for C. Once I simplify this, it will tell me what F is, which is the Fahrenheit, which is what we're looking for. So we have F equals 9/5. Instead of times C, we have it times 45 plus 32. Go ahead and reduce. So 5 and 45 reduce to a 1 and a 9. And that gives us F equals 9 times 9 is 81 plus 32. And Fahrenheit equals 113 degrees. I wish that was the hottest temperature we see in Arizona, but unfortunately that's a summer day for us. Alright, let's keep working with 2.2. We have another one that deals with a formula. So this is number 39, and it deals with the amount of unearned interest. So go ahead and take a moment, probably put me on pause, read through the problem, at least understand the formula, and then we'll go ahead and start plugging some numbers in once we look at the problem. Okay, welcome back. So we have a formula that is for the amount of unearned interest, finance charges that need not be paid. So this is money you would be saving by paying something off early. Okay, so U is the amount of unearned interest, money saved. So this is how much we're going to save when the loan's scheduled to run N payments. So if you have like a 12-month payment or something like that, is paid off X payments ahead of schedule. So this means we're going to maybe try to pay it off 2 months early. How much are we going to save in finance charges? That's what our formula is going to do for us. And what we need to know is the total scheduled finance charge. Okay, so let's see the problem we're working with. I'm going to move this down as we work. Okay, so it tells us that the finance charges on a loan taken out by Kali is $380.50. So this is the total finance charges. So the total scheduled finance charges is F. So that's going to be our F variable. So we may want to try to label that. If 24 equal monthly installments were needed to repay the loan, okay, so the loan is scheduled to run N payments. So this is my N. And then the loan is paid off in full with 8 months remaining. So that's how early we're going to try to get it paid off. So that's K. Okay, so we have K, H, F. Those are the parts we need. Or sorry, that's an N. I can't read my own writing. So that's an N, K, and F. The U is what we're looking to find. So once we plug everything in, should be able to simplify. Okay, so I have U equals, the F is $380.50. So 380.50 times, I'm going to have a fraction here. K is 8. So we have 8 times 8 plus 1. On bottom, we have N, which is 24. So 24 times 24 plus 1. And we have everything plugged in. The only thing we have left is go ahead and go through order of operations, simplify it, try to get to where we need. All right, so we have U equals $380.50 times 8 times 9. So 8 plus 1 gives me 9 up there. On bottom, I have 24 times 25. Okay. So from here, we're going to probably need a calculator. So let's go ahead and get our calculator out. Okay. So I'm going to go one more multiplication on top, and then we can, I guess, use the calculator a little more. So we have 8 times 7 on top, which is 72. And then on bottom, we have 24 times 25, which gives me 600. Now I can go ahead and try to reduce this, or we can just go ahead and multiply it since we're using our calculator. Remember, this is over 1. So I'm going to take the numerators and multiply them together. So I have 380.5 times the 72. That gives me 27,396. So 27,396 divided by 600. And then we go ahead and divide this by 600. And we have 4566. Okay. So by paying off our payment 8 months early, we're going to save $45.66. So it's just using the formula, understanding the formula, plugging the values in, and working your way through. Okay, let's go ahead and look at one from 2.3. 2.3 and 2.4 have a fair amount of word problems in them, so that's where you'll find a lot of your word problems. Okay, so we are looking at the John Hancock Center in Chicago, and it has a rectangular base. Okay, so rectangular base is telling me to draw a rectangle. And then now let's see what parts we have. The length of the base measures 65 feet, less than twice the width. Okay, so the length is equal to 65 less than twice the width. The perimeter of the base is 860 feet. What are the dimensions? Okay, it doesn't tell us anything about the width, so that means my width is W. Remember, with a rectangle, both widths are going to be the same, both lengths are going to be the same. So 2W minus 65. The idea is we want to keep all of these in the same variable, and the same variable. So 2W, and we have W's, so we want all W's involved. Now, when we're working with perimeter of an object, remember the perimeter is the sum of the distances around the figure. So we're going to take this, plus this, plus this, plus this, and that will give us the perimeter. So my perimeter total is 860 feet. I have one length, which is 2W minus 65, plus a width, plus another length, doesn't matter the order, plus the final width. The shortcut is 2 times L plus 2 times W. We combine like terms. So we have 2W plus W plus 2W plus W. So that gives us 2 plus 2 is 4, plus 1 is 5, plus 1 is 6W. Negative 65 and negative 65 gives me negative 130 equals 860. And then we solve. So add the 130 over. And we have 6W equals 990. Go ahead and divide by 6. And we have W equals 165. So this is feet. Well, it's asking us to find the dimensions, so that's just the W. We need to find the length. Well, the length is 2 times W minus 65. So what I need to do is take the 165 and drop it in to the W. So I have length equals 2 times 165 minus 65. And the length equals 330 minus 65. The length equals 265. So you do need to go through and find both of them. Once you have the first answer, you should be able to plug it in to find the second answer. Okay, so I hope that was helpful to get you started a little bit. Part 2 video will pick right back up with 2.3. We have some more word problems to go through, and hopefully these are helpful.